Welcome everyone for this last 20 minutes. My name is Louis Jacomet. I work at Gradle on the Gradle Build Tool itself. And today what I want to discuss is the fact that this ephemeral CI trend may have pretty severe impacts on your build times if you don't pay attention to the details. And given the topic of the conference, don't let it kill your developer productivity. So we'll go over the problem statement, look a bit in detail into the Gradle build profile, and then see the possible actions we can take. Problem statement is effectively what makes Gradle Build Tool performant, and how does that play with ephemeral CI or ephemeral environments in general. If you look at the Gradle documentation, we have a dedicated chapter where we will tell you a number of things you can do to improve your build speed. This is like enabling parallel execution, making sure you've got a Gradle daemon, turning on the build cache, increasing heap size, or even some specific optimizations for Java and Android projects, depending on what you're running. These contains a number of recipes, but of course, these recipes, when you're in the context of an ephemeral environment, may have different benefits. So just to clarify, this is definitely an industry trend. I mean, this is one of the reasons the Gradle Build Tool project can announce 30 million downloads a month. It is not because we have 30 million humans downloading the version each and every time. There are a number of machines in there. But it has definite benefits. You get isolation. You don't have state problems. You also get short-lived environments. So some of the mentions from earlier on, you've got leftovers processes, too many open files, files you can't delete. Like this effectively disappears. One thing I want to say though, is that if you think about ephemerality in the context of testing an application or testing a service, you usually don't test those on no state. You have state, whether it's a copy of production or a couple entries in a database, you're still needing some state to test things. But what you do is you have limited control state. So if we start from saying that ephemeral is no state, and we go back to our list, we can see that things like parallel execution, not a problem, like enable it. The size of the machine, you benefit from parallelism, your build will be faster. The Gradle daemon, well, the main benefit of the Gradle daemon is reuse. If you have a short-lived environment, you will use it once, so its direct benefits can't be guaranteed. The configuration cache, so Gradle has a configuration phase, we cache that phase, we reload from it. Well, if that state is gone, there is no reload, you'll just spend time caching it. Incremental build for custom tasks, not gonna happen because your state is gone. Enabling the build cache, yep. In terms of remote cache, that will help because whether your machine has any kind of state, it will at least fetch it and so not redo some of the work. Build for specific developer workflows or dedicated targets for your CI environment, of course, like you will optimize what gets run and not run what doesn't need to be run. Increasing heap size, it's just the same as parallelism. Of course, you can make it work. Just give beefier machine if it helps your speed. That's an easy solution. Optimize the configuration. I would say do that one anyway. It will benefit everyone in any environment. So that's a clear, no question asked. Dependency resolution, well, most of that chapter, which is not necessarily reflected in that title, is really about optimizing the downloads. But again, if what you download is not kept around, you will keep re-downloading every single time. And we're back to the potential 30 million downloads of Gradle Build Tool. And then finally, the optimization of these projects, well, that's really project specific, and I won't dive too much into that one. So when we think on the Gradle build side about the performance aspect, we see that we have three key elements that the build tool really provides. One is caching through the dependency cache, through the task cache, through a number of internal caches that effectively optimize by not redoing work. We've got incrementality, making sure we know what was executed before, know the delta, and when we can, just act upon this delta instead of redoing the whole work. And then finally, parallelism. Task level, test level, a lot of things in there. Once again, if you think about that ephemeral environment, only the last one is a guaranteed benefit. The first two, like the first one, caches, as we've said, it's going to depend. Incrementality is definitely gone. So if we assume now that we don't start from nothing, what can we do at the Gradle build level? Before we dive into that, let's see maybe an explanation of a build profile. What does Gradle do when it builds? So first of all, well, we need to start up the tool. Second, we have a Gradle configuration phase and then an execution phase. The bars are not at scale. I mean, they might be for your build, but they may not be for someone else's build. If we focus on the startup, Gradle being JVM based, yeah, you'll pay the price of starting up your JVM for sure. But if you have no state, the second step, if you use the Gradle wrapper, is to actually download the full distribution. Once that distribution has been downloaded, it will be used to start the daemon, but the first thing it will do is generate a number of files that are not part of the distribution because it reduces the download size. But of course, the cost of that is you end up generating these files every single time, potentially. And then finally, you have some daemon startup, and your build starts. We move now to the configuration phase. And in the configuration phase, we will need to resolve all these plugin dependencies that make your build logic. Once they're resolved, you finally get to compile that build logic. Of course, all of that will end up being cached and will end up being split into multiple dependency resolution phase to compile a number of build logic elements, then resolve the next one, etc., etc. And then finally, Gradle will build its model and the task graph that really needs to be executed. Once again, bars not at scale, like which one takes more time can really change and depend on the profile of your build. At the execution time, we get into, again, dependency resolution. This time, your product dependencies, the libraries you use for logging, your connectors to your different data sources, all of that. Then what I call inputs fingerprinting here is effectively the whole logic that Gradle has in order to determine whether or not it needs to do work. And some of that needs to happen even if there is no states. And then finally, we get to the task execution and your build finishes. So now that there is a bit of that understanding, what can we do? What are the possible actions? The first possible action is we're talking about performance and performance improvements. So don't do just blind changes, right? You want to measure the state you're in, do a change, measure again, compare, and verify that you have a benefit. Why? Because caching things, for example, is beneficial, but if we start discussing about moving things around or warming up machines, it may be that the cost of the warm-up actually dwarfs the cost of the operation happening. So, for the startup, well, first of all, Gradle comes with many distributions. Nowadays, with the IDE integration, always use the bin one. It's the smallest one. It doesn't have the documentation included, but your IDE is probably capable of downloading the documentation when you're looking at it. And on Ephemeral CI, guess what? Using the all and the documentation is probably useless because nobody will look into these archives. Of course, one thing you can do is if you create an image, a Docker file, or any kind of starting points for your environment, you can make sure that the Gradle distribution is part of that image. Or you just make sure that you download it from a closer location, or you can save and restore between execution the wrapper dists, because like it was said for Bazel, Gradle is really strong about being correct, and restoring its distribution is safe. Then you will run Gradle. And so in order to prime that distribution, you could, as part again of your image building, run it once, just to make sure that these generated files are created, are part of the image, and don't have to happen again. Or you can save and restore these caches, Gradle version generated Gradle jars. One thing I should say is that GUH is Gradle user home. So that's just a way to reference where things stand on your disk. Then we move to the configuration phase. What can we do there? So the first one is we can do something about the dependency cache, because the first thing we needed was to potentially download these plugin dependencies and build logic dependencies. Gradle comes with a read-only cache feature, which, for example, can be used to share a single dependency cache as a read-only volume in multiple Docker containers, because otherwise the cache itself is really made to be used by a single, it can be used by a number of Gradle daemons, but they need to be able to coordinate around its access. Or you save and restore caches modules too. The second step, the script compilation cache, similarly, you can use the remote build cache, because then instead of compiling all your build scripts, we will take the checksum of the fingerprinting of the inputs, verify if we have it in the remote cache, and download the result of the compilation. Or you can save and restore, and here it gets a bit more complicated because between the Kotlin DSL, the Groovy DSL, like you've got a number of locations that you may have to cache, and whether or not you use the configuration cache itself, you may have also to grab that JARS9 because we do some instrumentation to understand exactly what your build is using as inputs. Then in terms of dependency cache, in terms of the execution phase, well, once again, we go back to the dependency cache, but this time for your product dependencies. And for the task execution cache, again, we can play with the remote build cache or save and restore caches, build cache 1. And on Android, you probably want also the transforms because these are the way Android works by repackaging artifacts for different purposes in your build execution. So with that, when we look at the different steps of the build, we see that we can effectively really help a number of areas and then focus on the pieces that make sense and that are valuable for your builds. And interestingly enough, when we discuss that topic, we realize that often people are not aware of the benefits they can get and of the acceleration they can have from all of these. One of the things you can look at is we published a Gradle GitHub Action, and it has extensive documentation on the way its cache works, because one of the things you have to pay attention to is that, of course, if you save and restore things, you may accumulate more and more content. And so you may want to have steps where you actually clean up older versions that are no longer used, etc., etc. And that was pretty much what I had for you. Thank you.